We write tests to ensure our code works. With TDD, we even write it for code that doesn't exist yet, but it'll exist very soon after writing the tests. What if we could write tests against code that is written later, much later, maybe by someone else? Today I'll show you how to write unit tests that check future code. It's almost like raising your code coverage beyond 100%. It's a powerful way to prevent bugs, but more importantly, it helps you to shape your software's architecture efficiently and effectively. Since I learned about this technique, I applied it in every project I work on. For years and years, these unit tests have protected my team and myself from countless bugs that we would have introduced into the system. Stick around to see how you can apply this testing strategy right now, the small mindset shift it needs. And in the end, we'll look into a few pitfalls that I encountered over the years, and I'll show you how you can avoid them. Welcome to Frankly Developing. I'm your host Frank, and now that we understand the concept of testing future code, let's delve into why it's such a powerful strategy. Whenever we can anticipate a future issue, a future-oriented test can help prevent this from arising in the first place. Addressing them up front will save you time and effort later. These tests will further lead to higher quality software. Why? Of course, they prevent potential degradation, but more importantly, they force you to shift your mindset a little, to think about how your designs will be used in the future, how your architecture will play out in the future. By anticipating all of this, you're compelled to write cleaner, more modular code that's easier to maintain and extend. Keep in mind, this is not about investing into massive upfront designs. It's about the small or large design decisions that you already made and their immediate consequences. This might become clearer to you when we look at concrete examples next. You can see here that we have an animal enum with cat, horse and dog already in place, just like a standard enum that you might have in your programs. And then we have a feeder factory to create some feeder, which is some kind of interface to feed these animals. And the switch, depending on the individual animal, we have different feeders, A, B and C. You can also see that we already have a default case, like, oh, there's no support yet. And if we remove it, actually the IDE would complain that, yeah, you should add that in case some extension of the enum in the future comes into this place. So you throw this argument out of range exception in those cases. I hope you can relate to this example. Of course, designs that wouldn't require such exceptions and just always work would be much better. But often we have to do with less sophisticated approaches like this one. Now let's shift our mindset into the future. That future in which you are subscribed to my channel. Regularly get amazing content that helps you to become better with each video. Or to stay on the enum topic, let's imagine someone adds support for a new animal. So let's say we add our bird here to the animal enum. Now, usually we have some kind of program that does something and takes it as an input, and our designs, they can make up for that and give you the availability to input a bird now as a user. And if you run something like this, it doesn't work very well, right? It's going to throw us this exception, and of course we get back to the feeder factory. But now it might potentially be a bug exposed to the user already. At this point, we might have already lost. We do not want something like this to happen, really. So if we look at this feeder factory, it's pretty clear where this comes from. Sure, oh, we forgot to add a feeder for the bird. Now, if we think about this in advance, we might already write a comment here and say like, oh, don't forget to extend this. If you add a new animal, you need to provide for its feeding in some way. But then again, if we think about what we just did, we never looked at the feeder factory really. That wasn't really in our mind. It wasn't even open at that point. So maybe we should write the same kind of comment to the animal enum itself and say like, oh, if you extend this here, right here, then make sure you look into the feeder factory. But both of these are really, really weak. And there are even more variants that you can do in a similar way. Where you have documentation outside of your source code, where you have meetings to inform people. But all of these things, they basically come down to one and one only thing that is the trigger to me these days to think about these future proofing. Because each of those, it all goes something like, when you do this in the future, you have to think about something. And that by nature is guaranteed to introduce bugs, because we will not think about all of these things all of the time. Someone will have a bad day, might be myself forgetting about it after a year, and just not do what I'm supposed to do. Not read the comment that I'm supposed to have read. So this is a very, very weak way, and we want to look into how to strengthen this with an automated test. As you can see here, it doesn't take a lot of test code. It's just a very small unit test. The clue is in this enum get values. We use the reflection capabilities of our language to automatically, at runtime, go through all the enum options, all the animals, including new future animals that have been added sometime in the future. When you run the test in the future, it'll be different. It'll look at the current enum and take all of its values that are currently there, which means it'll also include the bird. It'll trigger the problem with the exception being thrown, it'll fail, and since you add this to your CI pipeline, you will essentially prevent someone forgetting about adjusting this feeder factory. Here is a similar but more powerful idea. You can see, depending on your reflection capabilities of your language, you can load all the data, all the types, their methods, how they use each other, dependencies, how they're named, everything. And you can load all of this into memory for a test that you can write. This, as you can see, is just a very simple demonstration of a naming convention. And instead of making it a simple convention and write it somewhere into a document, you have an automated test in your CI pipeline that whenever someone doesn't follow that convention, they get a failure and it's stopped, and they can just immediately fix it and adhere to this convention. You can see how this is much more powerful than writing a document, a comment, or telling someone about it and expecting them to remember. The example I've shown to you is just to get you started. But once you get used to this kind of thinking, you will get better and create way more advanced protection mechanisms for your design and architectural decisions. You can verify the presence of tests. You can check for layer violations. You can enforce certain components to couple to each other or not. The only limitation is the information you can get from your programming language's reflection capabilities and your imagination, really. But let's talk about the darker side of this, the pitfalls. These tests can lead to frustration, especially when you chain several of them. Imagine that you try to make a pull request, but a test fails and informs you that you forgot something. So you make your necessary changes and run the pull request again for another test to tell you that you forgot something else, and then another and another. And each time it takes as long as your CI pipeline needs to execute those tests. And the second, much more critical pitfall is that these tests are based on the current information available through reflection. Writing such a test is basically coupling your test to the current state of the codebase. In the future, this may deviate and potentially render your test completely useless without you recognizing it. Something as harmless as moving a class from one namespace or folder to another may result in the test no longer caring about it. And there's a lot of danger lurking in feeling confident that such a test is protecting you, where in reality it is not. I promised you to also give you the means to avoid these pitfalls. The first one is really simple. When you notice that there is such a chaining, just make sure that a test failure at the beginning of the chain gives you a really good output that explains the whole chain. That way you are informed about everything you need to do at once and you don't need to run through these iterations. For the second one, it needs a bit more experience to realize the foundational issue at hand. You couple the test to the current state of your codebase. Think about what this current state really looks like, what is important to the test, and then test for that as well. Say, for example, you want to enforce a decision that all subclasses of a certain set of base classes need to satisfy some criteria. Your test determines these base classes through some means. It might be a name, a namespace, attribute, or annotation. Whatever it is, you can at least make sure that the test still found some of these base classes. A simple assertion like making sure you found at least 5 of these base classes helps a lot. If you rename or move a package or directory around and then that contains all the base classes, it'll detect it and it will remind your future self to adjust the test for your future code. That may all sound very futuristic, but it's really down to a simple mindset shift of thinking about your code base's future. I hope you enjoyed this episode and you can make a lot of use out of these tests like I do. Thank you very much for watching and have fun developing.